All right, so I guess I'll go ahead and get started. I was supposed to have an interview with a gentleman, but sadly he got drafted into the war, so I'm going to have to interview myself today. He gave me a list of questions that I got to answer, and I'll try to answer them as best I can. So I guess let's just go ahead and get started. First off, first question, what is your name, and tell us about your project. My name is Gustav Hertz, and I conducted what's more known today as the Frank Hertz experiment. And we were trying to prove that there are quantum energy states and atoms, that they exist. And we did this by accelerating electrons through a glass envelope that is vacuum sealed with mercury gas. And we did this by taking an anode and a cathode and accelerating electrons through a metal grid. We increased the voltage in that tube, and the current increased as well as the voltage. When we hit a voltage potential of 4.9 volts, the current in the tube dropped to zero almost to an instant. Like we hit it and it stopped. And this tells us that 4.9 volts is the amount of energy needed to ionize the mercury atoms inside the glass tube. And within this excited electrons, it takes it to a higher quantum energy level. And therefore that means that the atoms they move faster and can now collide with those mercury atoms elastically. What were you guys trying to find? That's the next question. We were trying to find that there are quantum energy levels within the atom. We basically showed this by increasing the voltage from 0 to 4.9 volts. When we hit that, the electrons flowed freely and through the glass envelope, meaning that the mercury atoms in the electrons were on a lower quantum energy state, leaving the slower electrons to pass by them and collide elastically with them. And they were trying to change so that they can now change direction, but not speed, and keep floating by. When did this project occur? In 1914. I guess this goes into this next question. What was happening around that time? Sadly, the things that were happening were World War I, that happened shortly after, a couple months after. Like I said, that's we've already been through it for a little bit, and the interviewer got drafted in, so that tells you anything. That and Einstein actually proved relativity, so there's that. Kudos for him. Who else was involved in this project? It was me and my colleague, James Frank. We conducted the experiment in 1914. What was our roles in the project? Our roles were very similar. We were both trying to achieve the goal, or I guess the same end goal, of the study of electron impact and ionization of gas atoms. That's pretty much the same thing. Not much difference in roles, so there's that. Next question. What impact in the physics community, or I guess, what was the impact of your project or experiment? We did have an impact. The year before we did this, Niels Bohr created the model of an atom, which showed us that electrons take up the free space, or I guess empty space, of an atom, and that we basically just showed that that exist. We showed that quantum levels in the atom, and that it shows it like that. And even the year after, Einstein actually said that our experiment was so beautiful that it makes him want to cry. So, you know, hey, he said it, I didn't. The last question that he gave me, did we ever get recognized for our achievements? Yes, actually. The year after, we actually got the Nobel Prize in 1915. So that's that, I guess. There's no other questions, so hopefully I answered those to the best of my knowledge. I guess I'll leave y'all there. So y'all have a good one.